Hi, this is your host Swapnil Bhartiya, and welcome to a special edition of TFR Insights for KubeCon and Cloud Native Con. And today we have with us once again Sam Ramji, Chief Strategy Officer at DataStax. Sam, it's good to have you back on the show.
Rob, it's great to be back. It's great to see you.
Yeah, let's talk about the state of data and challenges in the cloud native space.
It's a great topic, and it's a rich topic. I think we're probably going to be digging in for the next 5 or 10 years, actually. There's a wave, right, that we talk about at cloud native, and it's kind of more like a tsunami, and tsunami is spelled Kubernetes. It's just moving through every organization that's doing computation and is kind of lifting everybody off of virtual machines and into the container world. So it's a lot more fluid. You can move from your local environments to your production environments, whether those are cloud or whether it's on-prem. They're all kind of acting in a similar fashion, and that's really helpful. The challenge, of course, is that environment was built for stateless applications, right? As we were building Kubernetes at Google and building out Google Kubernetes engine, working to make sure that it was open and well adopted through the CNCF with all sorts of other clouds. The whole focus was, how do you scale out stateless applications? It was later on that the question started coming up, like, what about the state that the applications are supposed to manipulate? Mostly those have been kind of left to, oh, you'll integrate it through a service broker. And the way that the data environment gets managed and scaled is like a completely separate thing. But you just leave that off to the side. What's changing though is that now that you start to see elasticity in your app layer, you want an application aware elastic data layer to move around, right, the cloud or on premises, wherever you see fit. So that's where the world of challenge begins, right? All the layers of data, whether it's your database layer, your data management layer, or your actual storage where you're writing the bits to media. All of those things have to become application aware, understand what Kubernetes is doing with the apps, and figure out how to provision that data in the right place at the right time at the right cost.
Also, one thing more is happening is, first of all, with Kubernetes itself, it is being used in so many use cases that were not envisioned by the creator in the very beginning. Number two is that because of this pandemic, suddenly every business is accelerating towards cloud and cloud native. So suddenly, the amount of data we are creating, and not only we are creating, we are accessing, and also business continuity is critical, because in cloud native world, you cannot expect to, hey, you know what, let's shut everything down on Sunday and we can, open the office on Monday. You cannot do that. People are building data lakes. At the same time, they want to process a lot of things locally. They don't want to be able to, and then they are also leveraging hybrid cloud, multi-cloud. So that is also creating some unique challenges. But the good thing is every challenge also brings opportunities, right? That's what you guys are doing. You're identifying the challenges and trying to solve it. So talk a bit about this changed landscape and what kind of opportunities it's creating for not only companies like, but also projects like Cassandra, where they are helping customers to continue to innovate and move faster at their own pace.
Well, it's definitely a super cool time to be part of the Cassandra project. And you made a really good point, which is that data is expanding. And it's expanding both in terms of original data, right? We're just seeing a lot more transactions coming through, especially in COVID. Businesses are switching from maybe 25% of their business was digital to 90 or even 100% of their business is digital. So of course, lots more data flowing through. The replicated data is growing even faster than the primary data, because now we're starting to realize the more that you can move, transform, analyze that data, the more advantages that you might be able to get in your business. So the total rate of data acceleration is absolutely spectacular. With that, as you pointed out, Kubernetes is ending up everywhere. So you're probably familiar with K3S, sort of a tiny minified Kubernetes. I saw Microsoft recently proposed a project for using Kubernetes as a standard for IoT, right? So when you start to really get all the way from where we've been with all these heterogeneous, disaggregated chunks of compute to where we're going over the next 5-10 years, which is a compute fabric that extends all the way from your laptop through the data center to a cloud, all the way to the edge, as you look at what Verizon, AT&T, T-Mobile are doing with 5G and edge computing, you end up in a very different world where there's going to be a very new normal. Part of that new normal is a container is a great standardized instance for compute that you can put anywhere that you want. which basically knows what it needs so that application can function. But on top of that, that application has to process data. So an application-aware data fabric in a world like this is a super cool thing to be building. So with Cassandra, it's the world's biggest data store, right? It is the most high performance available, fully replicated data store anywhere. It's an open secret that Apple runs all of iCloud services, including iMessage, everything else, on a couple 100,000 nodes of Cassandra. So it's sort of embarrassingly scalable, but it also scales down in a way that you can run it on an IoT edge device. And part of that scale is not copying everything everywhere. So the big exciting change in data to align to that uniform compute fabric that goes from your desktop all the way to the edge is intelligent replication. Which bits of data need to follow which applications around the world, and which ones can you leave still? So that's some cool stuff, is the ability to bring Cassandra and marry it to Kubernetes in a way that makes it more operable, more automated, and also more application aware.
Right. You mentioned K3s, and I think Kubernetes is also announcing their own. They're calling it K0s, which is once again targeted at IoT and edge computing devices. So, what is coming out from DataStax for KubeCon? Are you making any announcements as well?
Yeah, we have a big announcement, and I think it's kind of a beautiful serendipity that we're launching it on Dr. Eric Brewer's birthday. So it turns out his birthday is the 18th of November. For those who haven't kept up, Dr. Brewer created CAP theorem, CAP, consistency, availability, partition tolerance. And it is that theorem that is the basis on which databases like Cassandra live, because we realized you want to maximize your availability, maximize your partition tolerance. We can weaken the promises around consistency, which gets you kind of global scale. So for his birthday, ironically, we are taking two wonderful things, Kubernetes and Cassandra, and putting them together. So for some folks, maybe you watched the last conversation that Swap and I had. We have really been trying super hard to do the underlying engineering required to build Cassandra on top of Kubernetes. Databases in general do the hardest work of any component of a distributed system. Yes, the networking is challenging. Yes, the compute is challenging. But all the transaction coordination, all the race condition management, all of the locking, all of the things that you think about distributed computing that are hard, they end up centering that pressure on the database. As a result, most databases are monolithic. They have to make all of these huge promises, and the best way to guarantee those promises is to take no dependencies. But that makes them hard to manage. So the first thing that we did with Cassandra and Kubernetes was just make it run. So little Cassandra monoliths running on Kubernetes clusters. Then we took that and opened it up. So we broke the monolith. So a bunch of things like state and health reporting, metrics, control, start, restop, were all flipped around and reported out to Kubernetes through the Kubernetes operator. The most recent thing that we've realized is a lot of the operations that database administrators for Cassandra do manually can also be automated. Some of the things that you need to do in a cluster like Cassandra is anti-entropy repair, right? You have to make sure that the state of the whole cluster and all the data is being written properly all the time, and you have to kind of check that consistency, make sure it is kept up to date. There's an open source tool called Reaper, which takes care of repair. You also have to make sure you can back up and restore, because a database that goes down has got to be repairable. It's got to be restorable. So Medusa is an open source project that lets you do backup and restore for Cassandra. So what we've done is we've taken all of these different things, the metrics collector, the management API, the Kubernetes operator, all of these different components like Medusa and Reaper, and pre-built dashboards in Grafana and pre-built metrics collectors for Prometheus, and put it all into one distribution. And that is called K8sandra. So K8SSANDRA. It gives me a chuckle every time I think about it. So that's all available as a Helm chart. So people will be able to grab that and have an incredibly available, scalable database that just runs natively on Kubernetes and run in their cluster. So you can have your key space, you can have your key value pair, you can have an environment that's just going to do the things that you need. And when we get around to the new release of Cassandra 4.0 later in the year, that Helm chart will just update. You'll be able to pull down 4.0 and you'll be able to run that. So we're really excited about Cassandra because automating and creating elastic scalability in the most proven open source database that exists and marrying that with the consistency and sort of automation of Kubernetes, we think it's pretty exciting.
Right. Whenever I hear any project for Kubernetes, and there's always this word that reminds me of the KDE community because all their projects have K name in there. Even their own event is called Academy, which is with K there. Uh, one thing with Kubernetes is that as powerful as it is, there are too many knobs to be turned. So with Cassandra, I hope I said it right, Kate Sandra, right? Or Kate Sandra or Kate Sandra.
Kate
Kate
Sandra.
Sandra. How easy do you make it for people to leverage Kubernetes and all those tools that you're putting it together to reduce some complexity there? Talk about how it works.
That is super important. Smart defaults is a term that I've come across repeatedly, which represents really, really good design. I've had the opportunity to work with some incredible designers and product leaders like Oren Teich and folks who helped build Heroku. And a lot of what made Heroku great was smart defaults, because the more knobs you have, yes, you want access, but it's just kind of got to work for your base case in the beginning. And interestingly, I got a chance to work with Oren at Google when he came and joined us to take over serverless. Subsequently, you've seen Knative and Google Cloud Run and a number of things come out of him and his team. So we've taken that idea of smart defaults and we've really built it into Cassandra. We've taken a decade or so of DBA and SRE experience with Cassandra to make sure the configurations are right, the default correctly, and we've embedded those opinions into the Cassandra setup. What's really cool is the response we've gotten from SREs in the Cassandra community is that before Cassandra, the way that we exchanged institutional knowledge was on message boards. It was via email. It was via IRC. With Cassandra, based on this movement that Kubernetes is part of, which is sort of infrastructure as code, policy as code, you can encode your opinion. You can encode the smart defaults. So Cassandra will evolve along with the field of use and the habits of the SRE community that understands Cassandra and makes it run well. So that this can become a sharing environment where it just gets easier and easier to operate with more and more people sharing knowledge, not just in the code itself, but in the configuration, in the settings, in all the other things that you have to do. So the knobs are set to the right thing to start with. And if you need to tweak them, then there should even be some recipes that say, oh, for these particular use cases, you might just want to use this file instead.
I also want to talk a bit about security because security is becoming a very serious topic within especially the cloud that you work. It's no longer someone else's job. It's no longer an afterthought. I mean, Cassandra itself has, a couple of security authentication, mechanism. Kubernetes is not designed for security, but there is so many tools. So talk a bit about the security aspect of Cassandra, if there is any.
Absolutely. So one of the most important things is to respect the Kubernetes control plane. Right, that's something that the CAS operator, as it's called, the Cassandra Kubernetes operator, works closely with Kubernetes as a control plane to understand what are the commands, and those can be as simple as a rolling restart, which says, "Hey, get ready, I'm going to restart the boxes you're on," which for a database is a lot more severe than a restart for a stateless environment. So there has to be a little bit more give and take between a stateful workload and Kubernetes. But it also has to do a really good job of these more advanced topics, which you're pointing at, which is how do you manage credentials? How do you do credential rotation? How do you manage secrets? So Kubernetes has a whole secrets environment. HashiCorp's got this really nice tool called Vault. So that's kind of become a standard for how you manage secrets in Kubernetes around access. So Cassandra includes the ability to integrate with Vault to be able to do effective rotation of credentials, make sure that it participates in the same access control and coordination that everything else in your Kubernetes environment does. Because when you're thinking about the policy you want to enforce, how you want to govern your compute and data fabric, you don't want to have to do that in 3 different ways for 3 different components, because the complexity will lead to security holes. You want to make sure it's all working in a Kubernetes native way. So we talk about the world as if it's going to cloud native, But it's also pretty reasonable to start talking about things as Kubernetes native, because once we can start to isolate everything into one standard of practice, then we can all integrate with that. Infrastructure as code, policy as code, all of these things can work using Kubernetes as a common language.
Anything else that you would like to touch upon before we wrap this up? Or
Yeah, one thing that I think is really going to take all of us working together are these larger issues of security and policy around data over the next 5 to 10 years. There's a few different things that we need to have shared and not hidden. So, what are the standards for particular types of data? Should they be encrypted on the wire? Should they be encrypted on disk? What are the different access and recovery policies? What should be replicable? What should not be replicable? What should be backed up and restored? And what should be isolated? So there's a whole bunch of concerns. That's just at the data storage layer. But as you get broader into the environment, you start to see that there's field of use issues with data when you get into AI. So the big change that's happening in COVID is not just that data is growing for its own sake. And it's not even just that people are using more apps. It's that with this influx of data and apps, we're making the apps much smarter. So we're taking enormous quantities of compute and dedicating them to training ML models so that we can make everything work better for you. What's the ML learning? What are the inferences that the ML is making, right? We want to make sure that those are done in a coordinated, ethical way that's consistent with policy. We don't want a bank making a judgment about whether or not you get a loan based on information that it shouldn't have, right? That it should not legally be able to make an assessment about. So there's a bunch of stuff that we need to do as a data community to say that the data's got to be more automatable. The policy, the governance of this data has got to be declared in a standard format. We have to find ways to coordinate across this massively heterogeneous landscape. Because when you think about what do you use for data in your environment, if you come back with less than 12 technologies, you're probably running a fairly trivially sized organization because you've got people who have to do the hardware. You've got to deal with passing all those messages via networking. You've got storage, you've got access, you've got a whole range of different technologies, not just for each silo. ML is about bringing all the silos together so you can make smarter inferences and do better things at runtime. So with an eye towards AI, we all have to do a better job, not just of tagging the data, but just for articulating fundamentals of data policy that we can then all coordinate on. To summarize, Kubernetes is transforming the infrastructure landscape because it's taking us from imperative to declarative. You don't have to give a point-by-point recipe on exactly how to get your infrastructure going the way that you want. You simply say declaratively, I want the infrastructure to achieve this state, and you let the infrastructure sort it out. We need a Kubernetes API for data. We're still in an imperative world for data. We need to move to a declarative world for data so that we can just make it easier and tractable so that businesses and organizations can move faster with less effort.
you bring in some very important or very, very kind of could be controversial point as well, because one thing more that is happening, especially with edge computing, where you are not only processing, not only putting all those devices near users, you are also trying to process everything locally. And at times what happens is that since the amount of data you can collect versus how you can run analytics, you're trying to collect as much data as you can because you don't know the value of that at this point. So when you talk about the point of ethical, it's going to be very serious topic, and it's good to hear that, So is it something that you feel that should be done, or is something efforts are already going on in that direction?
I'm having really excellent conversations with a bunch of people around the industry. I think this is an idea whose time has come. I think a whole bunch of us, you'll find, start talking about this more often and with more authenticity and more courage. And I think a number of working groups will form. I'm working on putting one together right now. It's a little too early to take up people's time with that, but I am super interested in being in conversation with other people who are trying to solve the same problem, because the interdisciplinary nature of the problem means we need to have a diverse and inclusive set of people working on it, because the things that are obvious to one person aren't obvious to another. But we need both of those backgrounds of obviousness. Let's just say that the technology and the ethics have to come together. So in many cases, some of the most important people in these conversations will be the least technical. So we will need to marry, right, the technology and the liberal arts, as Steve Jobs famously said, in order to create a world that we actually want to inhabit now that it's being mediated by more and more technology.
One thing that I also noticed is that, especially in the cloud area, where the Linux Foundation is doing is that it's an umbrella of umbrellas of foundations. So there is a lot of cross pollination is going on because they have a lot of AI/ML project, they have a healthcare project. So they do bring a lot of people from different walks of life. And as you also mentioned, a lot of people are not technologists. They come. So how are these kind of like? Unfortunately, we will not be there at the physical KubeCon. Otherwise, you will actually walk on hallway track, you will meet so many people. So does open source kind of help enable these conversations? Because earlier there were silos where you do not even interact or talk to those kind of people.
I think open source is transformative because it changes emotionally how we feel about sharing deep ideas of technology. Right? When I came into the industry in 1994, there was a big thought of like secrets and, like we were trying to figure out how to encrypt things on the CD-ROM and, CD keys. Remember all that stuff, right? It was this idea that the technology was so scarce. It was like gold and we had to be like little trolls kind of holding it onto our own. But what transformed is with open source, we started to realize it's like open science. It's like the Enlightenment, right? It's positive sum game. The more of us who talk about the same things, the smarter we can all be. So the first thing that has to happen is ethically, we got to shift from zero sum to positive sum thinking. And you find a lot of open source people are embedded in that. So it's not that open source people are good or bad. It's just that when you practice this a lot, conversations just get easier and you're like, oh, I had a great idea. I want to share it. Somebody else goes, I was thinking about that. And here's what I thought. Awesome. Okay, what do we do next? And that's just fun, right? You can feel the energy. You can feel that positive spirit come up. And I think the Linux Foundation has done an extraordinary job. I obviously admire Jim Zemlin, Nitya Ref, the current chairman of the board, right? The leadership that's represented that whole community for some time. As you decrease the cost of collaboration, right, the value to civilization goes up. So I think the CNCF has done an amazing job. You can see the spread of ideas in that project, and it's just getting started. Look at what's happening there in telecommunication, in finance, in AI, in blockchain, right? Brian Behlendorf, famous from the Apache Software Foundation, leading Hyperledger. So there's so many different things that have just gotten much, much easier because of open source, and in particular because of what the Linux Foundation has brought to bear. I think that's a foundation that will be historical in scope. We'll still be talking about it in 100 years.
Awesome. Sam, thank you so much for taking time out today and talk to me about Cassandra and also the larger data landscape, a lot of ethical issues. And I look forward to talk to you again. I wish we could have done it in person, but I'm happy that we are able to do that. And the interesting thing is that most of the technology that we are using, even for this call, is based on a lot of open source technologies or technology that you guys are building there. So it's touching every aspect of our life. So once again, thank you not only for the call, but also for the technology that you guys are building.
Thank you so much. It's an inspiring time to be in the industry. It's inspiring to talk with you. And you and I go back a long way, right? I think we met like 12, 13 years ago. So congratulations to you on the persistence. I'm so impressed with the success of TFIR. And I just, it's a snowball. It's going to keep going.
Thank you. It's successful because of well-wishers of friends like you. Thank you.
Have a great one. Thank you so much, Swapna.